Thank you all for joining today. So my name is Debankur, and I'm super happy to be here and looking forward to talk to you guys about how search engine works. Before we get to that, real short introduction about myself. I started working in the various startups as an engineer, and then joined as an engineer in eBay too. And eBay is the place where I transitioned to product manager. And there was a brief time for a year I worked in a company called Quixie, and then currently head of search and recommendation in Apple App Store. Today's agenda, as the topic is product discovery, so we'll talk about what's product discovery, and then we'll cover how search engine helps in product discovery, and then we'll deep dive into some of the components of product discovery. And we'll go over with this term more detail. What does recall means? What does ranking means in search engine? And then the end we'll cover with how do we evaluate search engine? And then I'd like to keep some time for you guys about question and answer for that. Okay, let's see what actually is a product discovery. So the way I like to define is the ability for customers to find exactly what they are looking for in a reasonable amount of time. And there's a lot of heavy loaded word there. We'll go over it, but focus on some of the words here like customers, how do they find, and also the time. So these are the key words here, but that we'll see how it helps to get into our topic of product discovery. Now, one thing, it's basically, if you look at it, this whole discovery mechanism, it actually, the complexity grows depending on what kind of system you are building. For example, in the world of eBay, when you look at it way back, eBay was just an auction business. So where typically when you go with search perspective of it, the search is fairly simple. You go look at all the inventories you have, you see what items are ending, you sort it, you're done with the search. But if you move, as eBay moved to more like new items, or if you think about the Amazon search engine or any other search engine where the user interaction becomes more and more important, that makes the search engine way more complex. For example, it's not just one dimension search. Is it ending by price or sort by time? It also is what kind of interaction you are doing with the search engine. Is the quality of content which you are seeing, and these are the terms I'm just throwing it, but we'll go over more detail. Is the content which you are looking are more important? Is there any fraud there? Is the seller trying to fraud the system? How do you kind of include that? So when you fit all these information into search engine, the complexity actually grows for search engine really high. Now, looking a little bit into this, how do we do this? Again, like product discovery, we'll do it through search and navigation, of course. We won't cover navigation too much tonight. Primarily, we'll focus on search. But if you look at most of the sites, it navigation and search goes hand in hand. So navigation is kind of helping you to navigate through different information in search, and then search helps you to the way to think about it is search is a place where you know what you are looking for. You come to the site, you search for it. Navigation is more of a browse experience. You are coming to the site with a broader perspective that, hey, I might need something, but I'm not sure what I'm looking for. And that's where actually navigation helps you. So any search engine which you think about in today's world, it's actually a combination of search and navigation. They go hand in hand together. But as I said, today primarily our focus will be on search. We'll touch base some of these navigation related questions, but if you guys have anything in the middle, just feel free to ask. This is a very fundamental question, and where we run into is what actually is a search engine? Is it something like a database? A great example was when I was at eBay. And for a lot of people, the search engine is a black box. They don't really understand what goes inside, and they just search on it, and they try to find something. And when I was at eBay, in one of this interesting comment in one of these cases happened is hey, search engine, is it like database? And how do you kind of separate search engine versus database? So there are a few fundamental things. I mean, there's a huge lot difference, but there are a few fundamental things between these two which is important to understand. Both of these search engine and databases store data, of course, or the content. But in databases, as you probably most of you know, they run SQL. You can run SQL and get the information what you're looking for. In search engine, as I started saying that the ranking, as you saw I calling out ranking, the ranking becomes very, very critical, which database is bare minimal based on you can sort by certain parameter, but search engine helps you to include 100 of different things. If you look at today's scale search engine, whether you call it Google or Apple or Microsoft, that they consider almost over 100 to 150 parameters to rank certain items. Some of this ranking information could be quality of item, the behavior, how closely you are engaging with this. So you think that when you search for say Thanksgiving today in search engine, you are getting one result versus you come a week later, the ranking changes. The reason being your behavioral information is constantly changing. So all this information which search engine gets from different sources, and then they try to find out what actually best for you as a user and presented this. So this information is very dynamic, very n-dimensional information, and it tries to kind of help you to find best information in quickest and fastest way. Now, as I said earlier, while defining the what's the product discovery, as I said, is the ability for a customer to find exactly what they're looking for in a reasonable amount of time. So think of this customer as a user, and finding is actually think of as a platform which helps to find you something, and looking for is more content. So these are fundamentally three building blocks of search engine, which we will go in more detail about it. One thing which I didn't cover here is more in a quickest possible way. So that's a different aspect of how do you optimize, what's the performance and all those. So we are not going to cover that perspective of search engine, but we will deep dive into all these three components. So starting with content, what actually is the content here? So typically what we refer in the world of search engine, it's called documents. So any searchable entities, you can think of web page, or in the world of eBay or Amazon is a product, or in the way in the email, it could be an email. So anything which you can search in the web is called document or is a searchable entity. Now, having this is, how do we deal with this? So it's think of this, we need to parse this document to extract searchable information from this entity. And we need a high quality content because the content quality helps to make it more searchable and discoverable. And also think of it as if I have an unstructured data, plain text, the getting information out of it, or having in a free form or unstructured format, is a very tough job for search engine. So more structured the data is much easier for search engine to interpret. I will give you an example of eBay versus Amazon. So is Amazon, if you look at it, when you list a product, it's through catalog. What it means is majority of data is structured. You have a title of the product, you have a price, you have a description. It's a structured way. What it helps search engine to interpret those data much easily. Versus when you compare with eBay, even before the eBay catalog adoption is increasing, but eBay technically you can list anything and everything, and you basically go to eBay site and you can list a thing with a text in the information, and that it becomes a much challenging for eBay search engine to extract meaningful information from those data. So that's why if you see, and that impacts the quality of search in the upstream to the user. So more structured the data is, the much easier for search engine to interpret, and the end also it also helps customer to find those information much easily. And of course, the last point is more information is relevant people finding it more engaging with the content. So it's like, richer the content is, it's much easier for search engine to interpret, and it makes it easier for customer to engage with. Now, how do we make this content more structured? So think about this as like, and we'll go over how the schema looks like. So for example, in world of eBay or Amazon, you can have a product search. Think from another perspective of LinkedIn. LinkedIn allow you to search for a person, a job. So these are think about as an entity. So when you build a design a search engine, what it actually does is like, what's the purpose of your search engine? What exactly you are planning to do? Is it a product search? Is it a customer search? Is it a job search? Depending on that, you kind of come up with like, okay, hey, for product search, I at least need some mandatory field and some optional field. What does it mean? Like, for product, you need to have a title, you need to have a price. You can't, like, these are the very basic thing you need to have. So when you define a schema, you define that, hey, certain informations are mandatory for certain entities, and certain could be optional, good to have fields, kind of this. So if you, and this is a little more technical, but hope you guys get a sense out of it. So this is a typical, very simplified version of product schema, where you can see that, like, okay, I need the name of the product, I need description of it, and I need price. And you define at the end, the name and price are the required field, rest of the fields are optional. And that's how you checks and balances when you acquire the content. So think about it, it's like, okay, you have a search engine and you are allowing different product to be listed or different content to be coming in. So you have a schema validation in the front that, hey, for this content type, I need 3 or 4 different things which are mandatory for this content type, rest of the fields are optional. So that helps you to structure the content just so that, like, your quality of search engine actually is really good. So that was pretty much the first part or the first component of search engine, the content. Now, when we get to that, like the next piece is like, okay, I have the content. Now, how do I store it? And I will go into this term load. Let's not get too hung up on this. It's like, we index the content, and then we basically in search engine world, it's called inverted index. So we like, inverted index, and it's just an efficient way of storing data that directs you from Word to document. And the reason why it's called inverted is because the notion of storing, and I'll show you in a bit, is inverted. In like, generally what you like, look at the document, you go from a document, you go to Word. But the reason why it's called inverted, it's like other way around. You actually index the Word, and from there you try to find out the related documents. And that's the reason it's called inverted index. So this is how the process looks like. So you got a document, and the right-hand side is more representation of document. You run a tokenizer just to like, tokenize the whole entire document set. And then you'll normalize just so that every token has similar format or similar information. And then you store this in some format. So if you look at it, this is how the inverted index looks like. Again, this is very heavy on technical aspect of it, but even if you don't get the whole entire concept of it, but having this terminology like in your mind, it helps how this index is laid out. So think about this as the left-hand side is the index term. So it's like, all the document term which you have that gets stored, and then you have the number of occurrence. It gives you that like how frequent this whole entire term is inside the document. And the rest, like, right-hand side is more of like, how this is stored. So it has 2 lists technically. One is occurrence list, which actually says that like, where it occurs. And then the second is more like, how many times it occurs. So that's how inside the system, the whole content gets laid out. Now, before I go to the third piece of search engine customer, I'll pause here for a second. I mentioned a few of this thing and see if you guys have any question related to that. Yes.
When you are creating those tokens, does that mean that you have actually created tokens for each of the word in the document?
Yes, the question is, when you create this token, do you create tokens for each of this document? That's right. So, but you can have always, like in your smart engine, very depending on how you want to deal, like common word you can always drop. Like, for example, all these kind of very common token you can drop because these are so commonly occurs, you don't make out any meaning out of it. Okay, just as a quick recap, we covered two main components of search engine so far. One was more from content, and second is platform. So we are going to look into the third component, the customers. Now, the customer part of the search engine is really important and interesting part of it. So think about it is when customer comes to search engine, it gives you, or the customer tells you about what they're looking for in minimal 1 or 2 words. So if you look at if you look at the numbers, majority of query in our in Google search engine at this point is a length of 2.5 words. Almost 70 to 75% of the query occurs this. There are very few queries which goes beyond 5 or 6 tokens. So it's for the interesting part of this is customer is telling you with 2 or 3 words what actually looking for. And as a search engine job is to understand the intent of the query from those 2 or 3 words. So think about the example which I started with, like, okay, Thanksgiving. If someone tells you Thanksgiving, what's the right answer for this query? Is it like, Thanksgiving this year? Is it like Thanksgiving recipe? Do you want to show like, where do you want to go in Thanksgiving? And you can have all of this information as a part of search result, but now the challenge comes in, how do you rank them? Which should be in the top? What exactly the first result you want to show user? Because another thing which over time search engine has happened is like, anything beyond 5th or 6th result, no one even cares. So if you're like, in the moment your search ranking of an item goes beyond 7, 8, your click data really goes down. Beyond 10, forget it. It's like, there is better not to show it. So that's where understanding customer intent and what customer is like, just not literally understanding the word, but what's actually surrounding the word, what actually the inner meaning that has is a super important for search engine. And that leads us to the second, or the topic was like, query understanding and rewrite. Now, before I get to that, let me define a few terms which you will hear in general in terms of search engine. So the recall, you will hear this term like, oh, what's the recall for the search engine? What it actually means is like, the proportion of relevant document that are retrieved for a given query. So it like, when the way it works is like, you search a query, for example, you're searching for Chinese restaurant. So it goes to your whole content and it try to find out, okay, what are the document which I have has Chinese restaurant in it. So it picks up the recall set or build recall set from your whole entire content. And then the second piece comes in the ranking. How do we, once we have this list, like, how do we arrange those relevant documents from the recall set? And this is where every search engine actually differs. So it's like, I can say that, okay, give me sorting based on price. And even in the search engine, you guys probably have seen in the top, you can see that, okay, sort by price, sort by time, sort by relevance. Relevance is more of a heavy loaded term where like, different factor comes in and then search engine puts like, generally this is done through machine learning these days where you put different weightage depending on the user, depending on the time of the year, depending on 20 other things, and then you kind of see that, hey, during this time for this user, for this location, looks like this is the most relevant factor containing like 50 factors and with relevant weights. So that's where the relevancy comes in. And last is, of course, the precision. This is more of a measurement of the quality of search engine. Is like, okay, what proportion of the retrieved document are relevant, and how do we reject the non-relevant documents from this content? So that said, let's look into how this query is processed. So this is like, when a user types a query, it's getting rewritten fundamentally for two reasons. One is like, how do we address the recall, and then the second is how it going to help us in ranking perspective of it. So query needs to be annotated or rewritten to satisfy these purposes for recall and ranking. Some of these, and this is not an exhaustive list, as you guys can see, this is more of an illustration purpose. So some of this thing which we do it in recall is spell correction, query expansion. And for ranking, again, you kind of help with like, what's the query classification? What it means is like, if I say, for example, like board games, does that mean like, okay, what kind of games that is? So you help this ranker to classify what kind of query this belongs to, and which will help to rank accordingly. And we'll go over with this a little more. Now think about this. So this is a very standard way of query expansion. We go through stemming, we go through synonym, we go through phrase detection. One thing to call out here is this is a very typical in search engine. When you try to increase the recall, tendencies precision goes down because you are trying to add lot more stuff into the search result. As a result, your precision of the search engine goes down. The reason why I'm calling out is phrase detection. The phrase detection is a mechanism of way of increasing the precision, which can decrease the recall. Phrase detection is, this is like, as I was saying, the Chinese restaurant. So it makes sure that Chinese and restaurants are next to each other. So if I say that, okay, Chinese, like, market and restaurant San Jose, so the document won't be recalled if the phrase detection is enabled. So phrase detection actually helps to increase the precision, but it actually reduces the recall for that document. Here's an example. So how this query gets tagged or how the query gets annotated. So think about this. Someone is typing the North Face black jacket. So when we get this query, that get through a query tagger, and it labels this query in a various way. So it says that, okay, I know this North Face is a brand, and black is a color, and jacket belongs to, of course, product. So the way to understand, and of course the query classification, it says that, okay, this query belongs to, I am 80% confident that this query belongs to fashion, but I am actually 90% confident that this is a product query. So what it helps, so think of this as a knowledge base a search engine builds. When you send a query, it sends it to like, multiple knowledge base and tells you that like, help me identify different tokens inside the query and what kind of like, classes, what kind of information they provide. So that helps for, as I said, for two purposes. One is it helps to increase the recall. It helps also to the ranker to rank appropriately. Now, you think about this, like, this query North Face jacket. Now, if I write, so this is a very, very simplified way of writing this, like, which I showed you in the previous slide. Now, this is how the query gets rewritten. So North gets rewritten to various form, North Face, jacket gets pluralized to jackets, so on and so forth. So that like, when the reason for doing this is you don't know in your content what format this is stored. So you want to add all possible combination of different terms inside the query just so that when it goes to content, it can find out the matching content related to that. So that's the reason why the query gets rewritten or transformed in all possible ways. Now, as you can imagine here, when you are actually doing this, you're also triggering a false positive. So for example, North Face together, or like, knots, it can trigger a false positive there also, that some document might have knots which has nothing to do with North Face technically, and that can get recalled. The trick here is like, if you have a really good ranker, that will rank the appropriate information on the high related to your query versus all false positive gets on the bottom of the list of the ranker. So it's very important is like when you open up the gate with more and more recall, you need to have a really good ranker which can actually help you to rank the appropriate information on the top. How the knowledge gets built. So knowledge gets built in multiple ways. One is you can build over time from your query log. So you kind of look at your query and see that what exactly people are asking for. Excuse me. When, for example, say the North Face, it's a brand, you know about it. So you look at the query and say that people when they say North Face, they actually literally mean the North Face brand. So very first thing which you do is you look at your query stream and see what people are converting. For example, another great example is lift versus LIFT and LYFT. Okay, so you over time see that people actually is misspelling LYFT as LIFT. But you see that when people actually typed LIFT, they eventually actually start calling your ride sharing app. So this is the knowledge you look at inside your query log to find out, hey, people have typed the word LIFT, but what they end up doing at the end. So that's how you follow, which is called as a clickstream mechanism. So you follow user clickstream to identify what people have actually converted, and that's where you want to create the knowledge base. That's number one. Number two is you go, actually Wikipedia is a great knowledge base. So technically you can go to any source which is very authentic source, which you trust, which you build, and then you kind of extract information from there. The problem with just having clickstream as a knowledge base is, say for example, if your system has never seen a query, your clickstream has no information. In that case, you will not be able to identify what it belongs to. Okay, so that's where the third party outside world is always very helpful to build those information. So it's not just one source, you touch multiple sources, but only thing which you need to make sure that the information which you are getting is really verified, really authenticated, really someone is looking to make sure, because this is literally knowledge. So you don't want to have a wrong knowledge there. So that's why when you build this system from scratch, so there are two things. It's basically what we call it is a cold start and bootstrap process. So you have to rely on, so two ways to do is, you start with hand tagging. So literally someone is building this knowledge base as a dictionary or as a whatever the knowledge base literally, or you use from the external source, because you don't have any user which actually will give you the clickstream information. So you rely on outside mechanism to do it. But that said, what you can do, or generally company does is, say for example, you are building a search engine for travel, and travel is and you've never seen any query, you don't have any user, you're starting a search travel. So what you do is there are very good site for travel, for example, Travelocity or other sources which you trust that any kind of travel, they have been around, they know what travel queries are. So you kind of get information, their knowledge there, and you can get information for there. So that's a bootstrap or cold start mechanism. Expectation is over time, your customer, your query, you will come and then you will build your or enhance your knowledge base. So think about it when you go to eBay or Amazon, when you see you're searching for black shoes. If you see 10 results, you kind of feel that hey, eBay only has 10 black shoes in the inventory, there is something wrong there. Versus the same in Amazon catalog, it's a huge catalog. And you're showing 5 or 6 or 100 results for a popular query, that becomes a very, very unintuitive for a user to do. That's number one. Number two is also the performance. When you kind of think about it, when a search engine shows it's showing 1 out of 1 million, and it's showing out of within a fraction of millisecond, that kind of says that hey, these guys process information really fast. And a lot of time what happens is in a lot of search engine, if you look at it, you can't even go beyond 7th pages. Even the 7th pages is 100 pages, 700 items, that's pretty much it. But they still show the number okay, I found out of 1 million this 700. So it kind of gives you a perspective that few things. One is how fast the search engine doing is, what exactly are they showing top 500 or top 10 out of how many items. And the second is also it gives, as a user, it gives you confidence that hey, this is a big search engine and it's able to find this item what I'm looking for. So it's more not I'm missing out on anything. Okay, I think you asked another question, how do we build the ranker? So ranker is nothing. So ranker is a very broad term. Ranker is more of a sorting mechanism, right? So it's like you have certain information which is called recall set, and then it's like, think of, I don't know, think of a data structure, linked list, or whatever it might be, and then you sort based on certain parameter. Okay, the simple ranker could be based on, which we call it as a deterministic ranker, is based on one parameter like time ending soon. Okay, there is an auction going on, and there is all the items which are listed are sorted by the time, or it could be price. Okay, or it could be some other mechanism of a price high to low or low to high. The complexity of ranker goes high when you start including the behavioral data into the ranker. For example, what's the quality of item? Are those items real or fraud? What kind of reviews users are giving? Do you want to feed those information into ranker? Now also it comes from, so these are all what I mentioned was more from the content side of it. Now think from the customer side of it. It's your location. You are looking for Chinese restaurant nearby. You need to provide ranker your geolocation to kind of see that what nearby means, because your nearby query completely changes when you are in Santa Clara versus San Francisco versus somewhere else. So these are the information when you start feeding into ranker, the complexity of ranker grows high. Think about this, when you build a ranker, right? What's important to you? What's your business model? What do you optimize your search engine for? So you can optimize your search engine for, hey, you know what? I don't really care about the color. I care about brand. My goal is to promote high brand. Okay, so you tell that ranker and you put high weightage on this particular value called label called brand. So it looks at it hey, on all the inventories which I have, what all inventories has brand. So it identifies that and put a high weightage there just so that it can rank higher. Versus you look at black shoes or black jacket. So forget the North Face. So you have a query like North Face black jacket, and the second query is black jacket. If your search engine is optimized for brand, North Face black jacket will come high because you told your ranker that, hey, put heavy weight on North Face. So that's how the ranker gets decided. So this is where the recall precision comes in. Okay, so technically what you do is if you want more, and also the phrase detection comes in. So if you put two quotes at the end, you're kind of telling search engine that, you know what, I want to respect the word order. Okay, if you do not tell anything, most of the search engine today we have, they try to not respect the word order. But you can always build your search engine that by default, I want to respect the word order, and this order basically kind of takes precision. So that's two extreme case. The moderation case, which is okay, I want to include all the inventory which has not black jacket, but I want to rank the item which has North Face jacket next to each other. So that becomes a ranking function into ranker that, hey, recall is perfectly fine, include everything what you have in your inventory, but when you rank them based on the word order. Okay, so it depends on how you want to optimize, how you want to build it. So most general search engine has more than few hundred, and it's a really complex, and I'm here I probably have some slide I will show you, but I'm really simplifying this whole information just for understanding purpose. But think about a scale of few hundred rankers, and you are putting different weightage on it, because the way to think about this is everything what you do needs to be fed into ranker just so that can make an intelligent decision. Every aspect of the content that needs to be fed into ranker just so that it can make an intelligent decision. So if you look at if you guys are aware more of machine, these are the features of machine learning aspect. So it's an extract more and more features and aspect that. Another thing to keep in mind is this is more of for search engine and I'm just like hesitant to throw those terms, but it's like more of like for machine learning is done in a decision tree. So what you want to do is you don't want to be too reactive to it. So for example, like a user changes from Santa Clara to Sunnyvale and you completely want to change the search result. You don't want to do that. So you want to have a transition period or gradation. So these rankers weightage are chosen such a way that influence of this ranker is enough but not too drastic. And that's the reason why you see hundreds of rankers contributing to every search result. So it can be done it's generally done in two ways. One is the query rewrite I showed you. So you can kind of rewrite your query that, hey, C++, when someone is searching for C++, it's not just C++, it's C++, Java, or C, or any other kind of stuff. So what you're doing is you are trying to understand the intent of the user. Intent is like a user is actually telling me C++, but that person is not actually interested only in C++ in any object-oriented. So two ways to do this, or generally search engine does in two ways. One is you play this mechanism in query rewrite. So you rewrite C++ query as C++ or Java or object-oriented or Python or anyone you want to expand it. Or there is another way to do it in the content side. So when you are getting a content with C++, you also index the other related word to C++ just so that when the query comes in C++, you also return the Java along with that. So all this expansion can happen in either side. It can happen in the content side or it can happen in the query side. Generally, the rankers are built like, okay, this ranker is more for my price. This ranker is more for my time. This ranker is more from my user engagement. This ranker is more for my download. So you build all this individual ranker, and then you and then within this individual ranker, think of this as in each of these individual ranker has 100 of parameters or features extracted from it. So it's the dimension is very wide. So each of this 150 or 200 ranker, each of them within that has 100, 150 features, and then when it comes to that is how do you put different weightage to that, and all together when every query is run through the search engine, they go through that to generate the most useful information for you. So you come up with, so that's a interesting question. You come up with gut feeling with the beginning to bootstrap the system that, hey, my weightage in this case, the example which I was giving him is my search engine is more of a brand related. So I like to rank the brand aspect of it higher. So you kind of come up with your weightage along that line that, hey, anything with a brand, I want to weight it and all those. But it's a very dynamic stuff. So over time you start engaging, hey, I put too much weightage on brand. It seems like users, they don't like it. So let me readjust that weight. So it's a constant readjustment. So it's in machine learning world, it's learning process constantly happening, and the weight gets readjusted depending on the user behavior. So it's like the word which in machine learning is called training and retraining the model. So you come up with a model and then you retrain it every day or every 2 days, because think about it, there are multiple dimensions changing. Your inventory is constantly changing. Your user base is constantly changing. So all this thing needs to be fed into ranker to generate the most useful information for you. So this is a very dynamic thing. Everything is very getting retrained and remodeled. Okay, we covered this. Now let's look at how search engine is set up. And again, this is more for information perspective and having a perspective of it. So search engine generally is set up in a grid structure. So think about this is your inventory, eBay today's world or Amazon today's world has over a billion inventory. And you cannot fit all this inventory information in one box. So what you do is you create a grid and cluster of this. So think about it is all these horizontally, your inventory is distributed across all the horizontal channel. And the vertical is more of traffic. As your user base grows, you increase this. So the way to think about it is for example, your a holiday season coming in where you have Thanksgiving or Christmas coming in. Suddenly you kind of see that, okay, you know what, my inventory is going to grow in my whole search engine. How do you do that? You started increasing your horizontal because your inventory is growing, you need more boxes, you started growing in this way. Then you realize that, okay, you know what, growing inventory is not just one dimension. During holiday, I'm also expecting more traffic to come into my system. Then basically you kind of go vertically that, okay, I need to grow vertically also. So this balancing act always continuously happen in any search engine depending on the inventory and traffic. What's that? Yes, yes. I'll show you the zoom out view of this. So think about it. It's like this is how a query generally in search engine get executed. It gets to aggregator, and the reason why it gets to all the column is because your inventory is spread across all the column. So you don't know ahead of time where exactly this document for this query is going to lie. So you basically go everywhere to see that, like, you know, hey, this is the query, this is what user is asking for, do you have this inventory? Once it goes and it kind of looks at it, so this is more of like, you know, each column is a duplication. The reason why you need more column, as I said, is more of supporting more and more users. So it's like, you know, one row is not going to have, like, you know, support more than X number of users. So you need to grow vertically also to support more users. So once you find this, you see that, okay, the query which I was looking for, these are the red boxes where your query is present. Now you kind of go back and give the user the view. So just to answer your question, so this is how a very typical grid looks like in search engine. So you think about a client there, and then there is an aggregator sitting on the top, which actually gets the information from there. And each of this, think of as a different grid which is evaluating your query at runtime. Now we found the product, and this is where the ranker comes in. How do we optimize that, like, you know, so that, like, you discover what you're looking for in a minimal amount of time? So this is very typical or very simplified version of rankers, which you can see. Okay, the ranking factors could be trust. I want to get the information which has very low defect rate or very low high value of trust. Then there's, like, you know, okay, I want to look for also the price. I'm a price bargain person. I want to look for the inventory which has good in price. Secondly, more of textual data. So textual is more, okay, I'm looking for Chinese restaurant. Again, the same example. Show me the items which has, or the information or the content which has a Chinese restaurant. So that's where the structure data or the textual information comes in. And the last is super important, is the behavioral data. Also include this behavioral data factors into ranker, just so that it also engages, like, you know, okay, what users are looking for. Now one thing is getting more and more popular in the world of machine learning and search engine, what's called classifier. So classifier, the way I like to define, is the algorithm assigns one or more level based on some previous knowledge. So there are few classifiers which are very commonly used in search engine. First is more of a query intent classifier. What it does is, like, you know, it consults the knowledge base and try to find out what's actually the intent behind the query. As I said, like, the users are giving you query with just 2 or 3 words. It's important or, like, interesting to understand what's the hidden intention or intent behind the query. So this the job of this classifier is to find out, okay, user is telling me that, like, you know, it's looking for Lyft. What does Lyft means? Is it, like, you know, ride sharing apps, or is it Lyft as an elevator, or what exactly it means? Because there could be a very well a typo and I'm not able to understand, misinterpret that. So having this query intent classifier, it helps you. Similar with tagging system classifier. Entity detection classifier is one of these, like, you know, okay, query comes in as a software developer and software engineer. What it does is, like, you know, ideally your software developer and software engineer is technically same. There is difference, but there is the same, like, you know, you can show the result for one or other. So this entity detection classifier comes in and say that, hey, whenever a person is searching for software developer, actually software engineer is also fine, so have that information into this query result also. Spam filter classifier is another to identify that, like, okay, how good your content is, where exactly it's spammy, or how do we handle that. Now let's get into our last topic, product evaluation. Before I get into that, let me pause and see if you guys have any questions. Okay, let's get into how do we measure quality of search. So this is a very high level list or the process which actually followed through. So you have, when you build a search engine, you make certain assumption that, hey, I want to make a search engine and these are 100 or 200 or 500 queries. I want to make sure that this answers perfectly. So that's where the golden set comes in. Like, you have a golden set query, and there's a very first step which you do is validate against your golden set, like, is it working as expected? Once you do that, then it goes to the dog fooding. It's the terminology, it's pretty much in most of this large company they use. Like, the idea is what you build, you kind of taste it also. So it's like, you socialize within your network inside the company, or make it accessible to a little wider audience that, like, hey, I built this, see what's the relevance, how it's coming, what exactly it looks like. A/B testing is, again, you have, like, constantly updating it. You check A versus V. Is this the one which I want to more emphasize now is more of DCG, or discounted cumulative gain, and there are different flavor of it. The way to understand this is, like, there is a team of, and this is pretty much standard followed in the industry these days. You have a team of human judges sitting there who helps you to evaluate the search engine. And to answer your question about spam, so this is very easy for them to figure out that, okay, this news is a fake news or spam news. And then where it comes into the machine learning comes into picture is, like, you hand label that data, and then you say that, okay, any information related to this is kind of spam. So the machine learning takes that information, hand label information, and then feed into Ranker. The way to look at it is a scaling issue. So you have a team of judges which actually helps to label the data, and then you feed that information into your machine learning Ranker to scale it. The thing which you see here, DCG at 10, DCG at 5, 3, and 1, the reason why you see this kind of scale is, think about it, it's like, okay, you have web, phone, iPad, and watch kind of experience. You are building search for different of these devices. So for devices like, web, or like, computers, like, top 10 results are the key. People do go scroll top 10. But when it goes to iPad, probably 5 is more important. No one goes beyond that. Similarly with phone, like, top 3 results are the key. And if I go to watch, it's pretty much 1. So it's like, what it tells you is, like, okay, depending on device which you are building your search engine for, what are the key metrics, or what are the key area which you want to focus. If you are building a search engine, mobile search engine, primarily for phone, your focus should be, how do I optimize DCG at 3 parameter versus, I don't really care about DCG at 10 because no one is going to go in that deep. So that's where this notion comes in. Now let's see how this is done. So typically what we do in this kind of method is we sample 1,000 queries, and 1,000 is just a random number, but somewhere around that number. What it actually gives, when you sample, is this is more of a representative set of your query set. So this is like, think about it, is like this 1,000 queries is probably going to be used by most of your majority of your user base. So this is a representation of your user base for that. For each queries, you go to search engine and see that, like, give me top 10 result. Again, this is where we are going with DCG at 10. So think about it, if you are going for DCG at 3, so probably you will just get DCG 3 results. So you take top 10 results of that, and then you ask your human judges or expert that, just looking at the query versus the content or the result, label it between 5 to 1, 5 being perfect and 1 being unacceptable. So they look at it like, for this query, I'm seeing this result, and what exactly the scaling. The key here is the human judges or expert, they don't know how search engine is ranking. So the view they get is actually like this. So for example, if you look at the first one, like in a PDF conductor, a PDF converter, and they just actually see the search result, and they are asked that, okay, show me if this is a good result in a scale of 5 to 1. Think about this, the one in the right bottom is like, your query is Slack and you're showing Alibaba.com. So of course this is an unacceptable result. So they don't know how search engine actually rank it. They just look at a query and a result, and they are given like, rank it. Now in the big companies, or like, when the search engines is a huge, this team of human judges are technically not allowed to even talk to the engineers, because they are doing their job in a way that like, engineers cannot optimize for this particular queries. For example, like, PDF converter is giving like, this. If you tell engineers they like, optimize that particular query to get boost up the result, which you don't want. You want to do this as a scaling mechanism. So what you want is this team to be completely separate just for evaluation purpose. Now after they do it, you kind of map it. So this is like, for example, a query Roadhouse. So think about it, is the left hand side is how your search engine has ranked it, and the right hand side are how your human expert has labeled it. So your first couple of results are great, but third result, think about it, is like, search engine has ranked casino for the query Roadhouse, which is clearly marked by human judges as unacceptable topic. Even if you go further down, like, there are some great results like in a Roadhouse Diner, which is ranked top, but this actually is ranked way bottom by the search engine, even though human judges says it's an excellent. So when you compute this at the end, this says that like, what, out of DCG at 10, your score is 3.5. So that helps you to understand what's the quality of your search engine at that point of time. Again, if there is a spammy content there, they can easily find out that, okay, hey, this is unacceptable content, or this is not acceptable, and accordingly your DCG score will go down or get adjusted. So this is a measure of quality in search engine, which most of the search engine follows. Like, they have an internal matrix like, okay, what exactly DCG score is for your search engine. Every time you build a new feature, every time you are, so this process constantly runs. Advantage of this, one of these things is there are a lot of spammy market happens in some of like, geographic decision. Like, so if your metrics, for example, when you're defining search engine, if your metrics you're optimized for download, for example, or like conversion, for spammy market, this is very risky because your download can happen because of spam content, which you don't really want. But if you are looking with a human judgment, that helps you to identify the quality of search with this kind of score that, okay, what exactly it lies down.
What is a good DCG score?
So DCG at 10 is basically, it depends, like, how much you want to go. So if you really want to, so think about this, like, you are building a search engine and you want like at least top 5 results to be either excellent or very good. Rest as reasonable is okay. So if you want to do that, your DCG should be score will be in out of 10, it should be in the range of 8 or 7.5. So anything below that, whenever it happens, that think about this scenario, you as a product manager, you kind of release a product, and then you kind of go to your human evaluation team and says, hey, I built this product, can you guys run DCG score to kind of give me the quality of like feature, and then they will collect the query around that feature and they will run it, and this is like, hey, your score is coming out to be 4 score, and anything below 6 we don't release it to production. There's something wrong going on.
So no one ever evaluates that 230,000 results that the cost comes up.
No, so it's a scaling factor, right? So it's like, the way also is the interesting number with search engine is the amount of query gets repeated. You will be surprised. Your 10% unique query actually contributes to 75 to 80% of your queries. And rest 10% which you see, or 15% are different queries which are changing. So any search engine, if you pick today in market, like 65 to 70 at least are getting repeated. So, and those are just 10% queries are unique queries. So evaluating, so that's what it happens in most of the search engine. Like, if you can optimize your search engine for 500 queries, your 70% work is done. But that needs to be really, really optimized. When I mean optimized by that. Okay, just as a summary or key takeaway, so we talked about three components of search engine, content, platform, and customers. And then we touched base on understanding ranking factors. And also the key here in search engine world is it's very dynamic. It's like constantly changing. Your content is changing, your user base is changing, your behavioral data is changing. How users are interacting, they are constantly changing. So that's why it's always the chasing problem is a never solved problem, because, and of course your spam and all those, they are also like in every day you see a new sign of spam coming in. So if you think about a spam problem which you fix today, tomorrow is completely out of date. You start from new aspect of it. So spam is a big problem or big open area for search engine research. That's pretty much I have for search engine. Yes.
So the GDPR, which is happening in Europe, so how does it affect the search in terms of the ability of the user?
Yes. So it's an interesting topic, and majority of all big players are looped into this. So I think what you're talking about is disclosing user about what exactly how they're seeing their search results. The key here is no company, no one is going to give you the secret sauce. Doesn't matter what happens. Okay. So there's more of a legal aspect of it. How much you want to tell it, how much they is a fine line. So from search engine perspective, they're not going to tell you, or they're not going to tell anyone what are the different factors they consider, what are the weightage they put in. And that's basically the secret sauce of most of the search engine. What they will tell you is more like, okay, if you search for this, like search for black shoes, we will make sure that you get a black shoes, but not like other kind of shoes. We will make sure that all the information which you have will be provided somewhere. So what generally the search engines are following is like somewhere in your search results, they're providing a link there that, hey, to know more about your search results, why you are getting this, go here. And then they have a write up there like, okay, these are the 10 best practices. And most of this search engine, they give you best practices. Example which I will give you about eBay is like the seller will always come to us and saying that, hey, what you're telling me to have a great title, you're telling me to have a free shipping, you're telling me to have a very competitive price. I'm doing everything. Why my item is not showing in the top? And that's what everyone wants. And the answer to that is like, no one is handpicking this. No one is like, okay, for this query, show me this. It's up to machine. You feed all this information into machine, and they kind of decide the ranking or rankers of this, how this item is going to be ranked. So all these search engines, they have a best practice documentation. With GDPR, what's going to happen more is like this best practices is going to be more enhanced, and there will be both customer side of it, there will be more consumer side of it, there will be more business side of it. So they will have little more clarity on that, but no one is going to give the secret sauce for search engine, but that's the core of the business.
Yeah, I don't think even engineering team wants to share with the
Yep, no one wants that.
Yes, they just tell you what you need, but they don't really say how they do it. That's their formula, and they don't want to keep it under the hood.
Yes.
For the DCG operation, what's the typical frequency of the human judge?
So
Is it like 24 hours, 12 hours or so?
no, it's 24 hours. So it's a constant process. Everyone is there. But think about it, like, when you do this judgment, certain judgment, they don't expire. So you have expiration time, because like, if you have, think about it, like, you are doing 1,000 query and DCG at 10. So you are pretty much like, querying 1,000 times 10, that many judgment you need. So if you are a small company, you don't have that many like horsepower to run this many judges. You kind of say that, like, if I judge an item, it's good for 3 days. I don't need to rejudge these items. If you have a really big team and all those, like, and very dynamic environment, you are saying that, like, okay, that's great. I'm ready to like expire all this, and I will rerun everything every day. So that's the balance you put in, like, how many queries you are talking, how deep you are going, and what's the team you can build in. Yes, so that's a great question. So how, as a product manager, you kind of diagnose, like, where the problem is. So you optimize when you build your search engine, you optimize for different parameters, right? Like, is it an engagement parameter, or is it a conversion parameter? Is it a download parameter? So you have your own KPIs or metrics associated with anything which you do. And then when you kind of do is like, when you start, like, you're constantly monitoring every aspect, every KPI is what you build in for. And then you're constantly monitoring it. Now you started seeing that, like, when, say, for example, for whatever reason, a conversion started going down. And then you said, like, okay, from this period to this period, my conversion went down. You start going back saying that, did I release something new during that period? It could be very well that, like, okay, I released something new, that's an easy fix. And it could be that, oh, nothing happened, I didn't do anything, why my conversion is going down? The next follow-up question comes in, is it seasonal aspect of it? It could be that, oh, nothing wrong with that. So it's basically elimination process. Like, nothing wrong with my seasonal aspect, is perfectly fine. Then you kind of go back, did I use some of this interesting thing is like, okay, you made a minor change in the UI, which appears that, okay, this content was more appeared as a click versus like, it's just a display. User started misinterpreting that information as a clickable button versus like, just a text. And suddenly you start showing that engagement started going down, because people started thinking that I can't even like, click on it because it just looks like a test. So these are like, kind of thing which you need to look more, and the best way to go is by elimination. So you kind of see that, okay, my sales or my conversion or my download is going down. Potentially there are like, 15 or 20 reasons. And then you kind of see, take one at a time, low hanging fruits first, like, okay, these are easy. And then you kind of come up with final 2 or 3 where you can deep dive, okay, this probably is the reason.
There are some categories, like how in some websites I see that you have searched for these products and they check the results or the keywords next to those things. Does that really influence the user?
Yes and no. So that actually helps when you you mistype it. So for example, if you see a lot of times, so you kind of say, and lift is a great example. Like, for example, you search as LIFT. And in that particular search engine, the most popular query is LYFT. So what they do is like, they auto-correct it, and they say that I am showing you result for LYFT, but did you mean LIFT? So in that case, you can kind of say that, hey, I don't want your auto-correction, even though that query is very popular in your ecosystem, I'm actually fine with what I typed LIFT. So that's why it's very important to kind of refer back to the user when you're taking control away from user and you're trying to automate some of these assumptions. So it's very important to kind of refer back to the user. Yes?
So, for example, with Google, right, how does when you search for something like a product that we use or whatever, how does the ads like affect the ranking? Because if I'm Macy's and I pay Google a lot and I want my, I don't care what happens, whatever the search words are.
Right.
I want my website to show first. Doesn't that mess with this whole system that you build with the people and the ranking? And the
Yes. So it's I will give you the example, and I don't know how many of you have seen or you had seen old eBay site. So there was a placement of certain items with a purple color on the top. The idea being that, like, you can buy those placement. Okay, so your top 2 or 3 is like, paid placement. So that kind of goes contrary to your search engine.
So is that like two separate things? Like that
Yes.
ranking?
So think about it is more of an injection. So a lot of time what search engine does is like, you can inject an advertisement or a placement somewhere, like, these days a lot of, like, you see search engine doing in the middle kind of stuff because they don't want to impact the top result. A lot of they do it in the right nav kind of stuff. Still a lot of people, they do it in the top. So it's a more of a company philosophy. The way internally it goes is more, everything is driven by money and revenue. So advertisement is a huge channel for revenue. So they kind of say that, like, okay, you know what, search is bringing up, say, $1 billion, advertisement is a easy money for, like, I can bring those money. What generally, like, again, and this, you're right, that goes is a counterintuitive to search algorithm for that. But what generally this company, they do is like, okay, I'm going to leave my first slot or third slot or whatever might be the slot for advertisement. You figure out what exactly it is, but make sure that it actually, from relevance point of view, it actually is a relevant ad. The moment you see that, like, they start surfacing irrelevant ad, I'm going to stop that. But generally you don't play with the placement, because that what happens in the user's mind, that when you go to certain site, you'll see that, okay, you know what, third site, I know that this is advertisement. So you set your expectation or set your perception according to that. But relevancy in a good search engine, relevancy actually plays a very key role for advertisement also. It's like, unless your advertisement is relevant, we are not going to show you.
So, good question. Do they need to basically come up front and say that this is an ad, or can they have in the algorithm more weightage for sources of revenue? I mean, if two sites are equally relevant for the query, just give one a higher weightage simply because they're paying ad.
So yes and no. So if you think about it, like, when you put some advertisement, you have to call it out that this is an advertisement. And people have a different perception when they look at advertisement versus search result. So people don't even, a lot of people, they don't even look at advertisement. They like to look at the search result.
No, so in the search results, do they have to, basically, can they just modify their weightages and not call out as an advertisement?
You have to. So from user perspective side, I mean, always, you can always do this, like, not, but general principle is, if it is an advertisement, you have to call it out. A reason also is, like, your inventories completely could be different. For example, like, if you go to Amazon, you can see the sponsored, like, items for there. And reason for this is that those are not Amazon inventory. They will take you somewhere else. The idea for that is, again, one is more for keeping the revenue point of it. Another point of view is like, hey, I don't have the inventory, but I don't want to lose my traffic or customer. So I want to retain my customer within the ecosystem. I'm just trying to help that person to find something even though I don't have it. So let's, like, give this user inventory even if it's an ad.
But there's no oversight to whether these things are kosher or not. I mean, if they are doing something in the algorithm itself, there is no way for them, anybody to basically test it out.
Well, users are smart these days. You can't trick them, and they figure it out that, okay, you know what, this is not an organic search result, this is an advertisement. And you don't want to play those games in the search result. It's having a, that's why I said having a fixed placement is the best option, because you set the user perception as that, like, okay, you know what, fifth slot is for advertisement, and I'm going to leave that part, let advertisement team comes in and figure it out. I want to make sure that advertisements are relevant. That's all I'm going to do it. Rest, I will let them figure it out.
I don't know if she meant advertisements, but I thought she meant that if there were two competitors, say probably, Amazon and Alibaba, and if somebody searched for an item, and if one of the companies said that, put me in the first 3 clicks.
Right.
And, because I'm paying you more, is that possible?
Yes. So that's always the bidding goes in, right? So that's more of an advertisement. That's more of, like, when the query, you send a query, you get a user query, and then it goes to a, like, advertisement whole system that, okay, who pays. So there are a few things they click on it. So, like, the money is not the only thing, also relevance also comes in. So is your, like, ad, what you are trying to show, relevant to the user? Is you have paid more? So there are multiple factors they evaluate before they kind of say that, like, show the ads. So it's like, advertisement evaluation, this is another beast altogether. They kind of send, and that needs to be super fast because your search result, before search engine comes in, you have to kind of show the results. Yes?
For example, sometimes you search, you see the results, and you order an item, and later after 2 or 3 days you said, the order item is not available. Isn't the inventory which your search engine is doing is not a real-time inventory, or why is that happening?
It can be any reason. One of the reason could be inventory, but like most or generally the good search engines, they have a good or very sophisticated inventory management system. So there is always a lag there. So it depends how that search engine gets the feed. The example which I gave is like there is a lot of online and on store business going on. For example, like they will allow you to buy online and then you can pick up on store. So buy online, pick up on store. That's a very popular model a lot of companies are following. But the interesting part of this is like the inventory feed that search engine gets from these different retailers, there's always a lag there. So unless this lockstep happens, there is a very high chance that like its search engine is doing something, but actually you don't see that. One example is more like in the world of eBay, like especially when like eBay was peak on auction business. So this auction bidding constantly happening, right? So this bid needs to be reflected in the search results in real time, because like if some sold happens, some auction happens, you want to show that to the user. You don't want to reflect that after like 2 minutes or 3 minutes. So that made eBay search engine even more challenging because of the freshness of the data. So the data freshness becomes super important for some search engine where your data is constantly changing.